Quicksort partitions a list into two sublists based on a chosen pivot element. Elements smaller than the pivot are placed in the left sublist. Then the pivot in the middle, while elements larger than the pivot are placed in the right sublist. This process is repeated recursively on each sublist until they are sorted. It is done if a sublist contains 0 or 1 element, and no further step is required. When all the sublists are sorted, the entire list is also sorted. Pivot can be any element in the list. One effective method is choosing the last element as the pivot. For example, we are sorting a list of 7, 2, 12, 10, 15, 4, 18, 6, 9. Pick the last element 9 as the pivot. Find the first element at position I in the partition that is larger than or equal to the pivot, which is 12 at position 2 in this case. From position I plus 1, continue to compare each element with the pivot till the end of the list. Switch elements smaller than the pivot with the element at position I, and increase I. At J3, no swap, because 10 is larger than pivot 9. At J4, no swap, because 15 is larger than pivot 9. At J5, swap with I2, because 4 is smaller than pivot 9. Increase position I into 3. At J6, no swap, because 18 is larger than pivot 9. At J7, swap with I3, because 6 is smaller than pivot 9. Increase position I into 4. At J8, we reached the pivot, swap with I4, and the partitioning is done. Now we have pivot 9 at position 4. The pivot position is fixed, and no need to touch it anymore. Because all elements from 0 to 3 are smaller than the pivot, and all elements from 5 to 8 are larger than or equal to the pivot. Continue sorting with partition 0, 3, and partition 5, 8. With partition 0, 3, pick the last element 6 as the pivot. Following the same steps above, we end up moving 6 to position 2, with the left partition is from 0 to 1 and the right partition is 3. The right partition is done because it has only one element. With partition 0, 1, pick the last element 4 as the pivot. The first element larger than or equal to the pivot is the pivot itself. So split here, and it's done because the left partition has only one element, and the right partition has none. With partition 5, 8, pick the last element 15 as the pivot. The first element larger than or equal to the pivot is 18 at position 6. At J7, swap with I6 because 10 is smaller than pivot 15. Increase position I into 7. At J8, we reach the pivot, swap with I7, and split. The right partition is done because it has only one element. With partition 5, 6, pick the last element 10 as the pivot. The first element larger than or equal to the pivot is 12 at position 5. Next, check at J6, we reach the pivot, swap with I5. Split at 5. And it is done because the left partition has none and the right partition has only one element. Now we have the entire list sorted. Quicksort is known for its efficiency and speed. It has an average case time complexity of O(n) log n, making it a go-to sorting algorithm for many applications. However, it's worth noting that Quicksort has a worst case time complexity of O(n) squared when the pivot is poorly chosen. For example, we pick the last element as the pivot in an already sorted list. We will have an empty partition with every partitioning, which makes the algorithm inefficient.